let's now try and find all x such that the following equality holds. Now this problem, it's kind of a tricky one to see how you could approach because, I mean, it doesn't obviously fit the pattern of any kind of my laws of exponents. We've got different bases and different exponents, so we can't easily simplify the left-hand side. We do see that the exponents are variables though, x and x squared, so it makes sense to try and use the laws of logarithms. So there are two bases, 2 and 3. Doesn't really matter which I'm going to choose. Let's do base 2 because we've seen that quite a few times and see what happens. So I'm going to take this expression, and let's hit it with log to the base 2 on both sides. So this is if and only if log to the base 2 of 2 to the x times 3 to the x squared is equal to log to the base 2 of 1. Okay, so now let's do our laws of exponents. This is if and only if. It's going to break apart as a sum, so this will be log to the base 2 of 2 to the x plus log to the base 2 of 3. So let's be incredibly careful here. All to the power x squared. Log to the base 2 of 1 is 0, remember, because 1 is equal to 2 to the 0. Alright. So now this is if and only if what? Well, I can always bring exponents down. If there's an exponent inside, that can be brought to the very front. It's one of my laws of logarithms. So this becomes x log to the base 2 of 2 plus x squared log to the base 2 of 3 is equal to 0. So I need to find all x that do this. Thankfully, log to the base 2 of 2 is just 1 because 2 to the 1 is 2. And this is going to be equal to x, just x on its own, plus, well, log to the base 2 of 3, x squared. I can't really simplify log to the base 2 of 3 as far as I can tell. Equals 0. So now what am I going to do? Well, thankfully I could factor out an x from the left-hand side. So this is x times 1 plus log to the base 2 of 3x is equal to 0. So now I'm going to do the 0 product property. So this is if and only if either x is equal to 0, of course, or 1 plus log to the base 2 of 3 times x is equal to 0. Those are the two options. So it's either that's 0 or that's 0. So I'm not labeling every step here. I'm not going through every single law like I do in the core video, but every step is one of these core properties. So finally, this is if and only if what? Well, x is equal to 0, or we could rearrange this, pretty simple. X is equal to, what is it? It's minus 1 divided by log to the base 2 of 3. You could do this slightly differently with a different logarithm base. You could do it with 3, for example. It would all kind of come out to be the same at the end of the day. So this is a really good example, right? It's quite tricky, but it kind of hits lots of the key beats about using laws of logarithms to do algebra.